Okay, so this lesson is Unit 6, Day 4, and it's on proportions and graphs. So let's take a look at our next slide. Our learning target is that I can use tables to graph and determine constant proportionality. This is the same idea about things being constant that we've been talking about for a while now. Constants and proportions. Okay, so the first part of our class notes say, use the information below to create a table and determine the constant. And we know to find the constant, we're going to use the equation k equals y divided by x. So we've been dealing with constants, with tables for a while now, for a couple lessons, and we know that the first column always listed will be our x, and the second column listed will be our y value. So it says right here, a bike rider cycles 18 miles in 1 hour. They do 18 miles in 1 hour. So how many miles would they bike in 2 hours? Let's go ahead and fill that out. And then in 3 hours. And the pattern right here is that he's just biking 18 miles more each hour. So to get that, what we could do is, for our next one, we could say, oh, he's going to bike 4 hours. We know he does 18 miles an hour, so we could do 4 times 18 to get our answer, which is 72. Now I could do 5 times 18 and get 90. And 6 times 18, and that gives us 108. And 7 times 18, which gives us 126. So our constant is our y value divided by our x value. And each time that we do that, we are going to get the number 18. So 18 is our constant. And in order for us to get this value right here, like I said before, you take your x value, which was 7, you times it by your constant. Our constant was 18, and that gives you the y value. So for our equation, let's go ahead and put y is equal to 18 times x. Now let's go ahead and write out some ordered pairs. Ordered pairs, you learned about this last year, and so it could have been a while ago, so I'm going to give you a quick review. Ordered pairs look like this. You have your x value and then your y value, and then they have parentheses around them. So if I am just moving my numbers over, I'm just going to do 1, 18, and I'm going to put my parentheses around them. 1 is my x value, and 18 is my y value. And let's go ahead and do that for the entire graph, or the entire table. What I'll be doing next is I'm going to graph these on the table to my right. I know that hours is my x value, because that's what my table is labeled as. Let's use purple now. Right here, it shows that my hours are my x value. And my graph over here, this is your x-axis, always, always, always. And you'll use this all the way through 7th grade and 8th and 9th and all the way up. And the vertical axis is your y-axis. The y-axis is always the one that goes up and down. And on our table, we know that our y-axis is total miles. So let's go ahead and label our graph. I'm going to have hours along my x-axis, and I'm going to have miles along my y-axis. And so I'm going to say total miles. And now it's time for me to start labeling these. I think I'll use a different color now. Let's see, hours that the bike rider bikes. He bikes up to 7 hours. So 1 hour, 2, 3, 4, 5, 6, and 7. And then for the miles, it just counts by 18 each time. So let's go ahead and write those out. 18, 36, 54, 72, 90, 108, and 126. Okay, now it's time to graph. Let's use a different color. When I'm graphing, I'm always going to do my x value first and then my y value next. Always. So let's take a look at this first ordered pair right here. It says 1, 18. So I'm going to go over to 1 on my x-axis, and up to 18, and I'm going to put a little dot right there. Let's do the next one, 2, 36. So I'm going to go over to 2 and up to 36. Next one, 3, 54, go over to 3, up to 54. And if I keep doing this, what I'm going to see is that my plots, they are making a line that goes all the way through. So I'm going to go ahead and just draw my line all the way through. It goes from 0 all the way up. Let's go ahead and draw an arrow at the end, because I know that if this bike rider kept cycling for longer and longer and longer, it would just keep going up in a straight line. So let's compare the two graphs below. It says jot down your observations in the table. Here we go. Here's two graphs right here. They say that they are proportional. Why are these two graphs proportional and the bottom two graphs are not proportional? What do we notice that's different? So with these top two graphs, the first thing that we notice is that both of them pass through the very center of the graph. And the center of the graph is also called the origin. Here's the center right here, 0, 0. So let's put that it passes through the origin, 0, 0. Origin. Man, spelling is so hard for me right now. And then let's put 0, 0. Just so that way we remember what it's called. Now, another thing that I notice here is that there are two straight lines. So that is also called linear in math when you go to graph. Those straight lines are known as linear graphs. So let's put that they both have a straight line. And now I'm going to take a look down here at these other graphs. They say they are non-proportional. I notice here this graph does not go through 0. Neither does this one. This graph is not a straight line, so it's not linear, while this graph is a straight line. So how come this graph, the very first one listed, how come this one is non-proportional? Well, it's because your graph has to go through 0 and it has to be linear. So let's write down here that, first of all, there is not a straight line. And the second thing we're going to write down is that our graphs do not pass through the origin 0, 0. All right, next slide. Proportional relationships, they are linear, just like we talked about on our last slide. Our proportional relationships need to look like this. They have to be a straight line that go through 0, 0. So, or the origin. So let's put here, proportional relationships are linear and pass through the origin. And if you need a nice reminder, go ahead and write in 0, 0. So let's graph the tables below, and we will explain if they are proportional or not. Let's take a look at example number 1. The table gives us our x value, our x values, and it gives us our y values. Every time you look at a graph, the horizontal line is always going to be your x value, and the vertical line is always going to be your y value. So when we go to graph this, let's take our first number where it says x, which is 1. And then let's take our second number, which is our y value, and it says 1. If it helps you, you can go ahead and write them out, but you don't have to. 1, 1. That would be right here. I go over 1, and I go up 1. Let's take a look at our next one. 3, 2. Oh, whoops, I did that backwards. 2, 3, because 2 is our x value. There's our x values, there's our y values. So I would go over to 2, up to 3. Let's do the next one. 3, comma 5. I would go over to 3 and up to 5. Next one is 4, comma 7. I go over to 4 and up to 7. I'm just going to keep doing that. It looks like 9 is not on the board, so I'll just have to make one up. And so our line goes like this. Now, I'm not sure right now if my line is proportional because I don't know if it goes through 0. Let's see if I were to take my table and extend the numbers to the left. Let's see what I would get. I can see, I'm gonna use a different color. I can see that my x values are decreasing by the number 1. So if I were to keep going down one more, I would get a 0. And I can see that my y values are decreasing by the number 2 each time. So 1 minus 2, that gives me negative 1. If I were to plot the points 0 and negative 1, let's see, 0, negative 1. Oh, it looks like my graph is not going to pass through the origin, but instead it's just going to miss it. So let's go ahead and write, for example, number 1, our answer is non-proportional. And the reason is because the graph does not pass through the origin. Okay, example number 2. We're going to graph these. My x value here, let's always start with the x value, and then we will end with our y value. Here's x, and here's y on your graph. So let's go ahead and graph negative 3 and negative 6. So I'm going to go over to negative 3 and then down to negative 6. See how I went over to negative 3 and then down to negative 6. I'll erase that and just put my plot. My point. Over to negative 3, down to negative 6. Let's do the next one. I'm going to go over to negative 1 and down to negative 2. Let's graph 1, comma 2. So I'm going to go over to 1, up to 2, over to 3, up to 6, over to 5, and up to 10. Let's graph our line. It looks like our graph goes right through 0, comma 0. And so for example 2, let's say that this one is proportional because it is linear and it passes through the origin. It passes through the origin. Maybe I should say through. Okay, let's go ahead and do example number 3 and let's graph these. I'm always going to start with my x value and then I'm going to end with my y value. So let's go over to 2 and up to 1 to graph our first plot point. Next one says let's go over to 4 and up to 2. Now let's go over to 6 and up to 3. Over to 8, up to 4. It looks like my graph is going to go like this. We need to figure out if our graph will go through 0, comma 0, because if it does, our graph will be proportional. So let's take a look at the pattern we're noticing. I'm noticing right here my x values are decreasing by 2 each time. So if I decreased by 2 again, I would get 0. I notice my y values are decreasing by 1 each time, so if I did it again, I would get 0. 0, comma 0. That's good for us. What this means is it passes through the origin. So this graph is proportional. And it's proportional for the same reasons. Number 1, our graph is linear. And number 2, it passes through 0, comma 0. Or you could just write it passes through the origin. We are learning a lot of new terms today. All right, and questions 4 and 5. Use your understanding of proportional graphs and tables to answer the questions below. The number of feet in a yard can be represented by a graph. which of the following graphs best represents y, the number of feet, in x yards? So in 1 yard, there are 3 feet. And it told us that, let's see, which of the following graphs best represents y, the number of feet? So feet will be our y value, and yards will be our x value. Let's see how many feet would be in 2 yards. If I had 2 yards, that means I would have twice as many feet, so I would have 6 feet. Let's see if we have a graph that matches that. Our x values, let's look for the numbers 1 and 2 for our x values and see if they match up with 3 and 6. So I'm going to take a look at graph A. It looks like when I look for 1 yard for my x value, one yard for my x value, and remember x is on the bottom. I'll write that on all of these graphs. It should match up with 3. So if I look at 1 and I go to 3, it looks like this graph does not pass through the line. If it did, it would go this way. I'm going to look at graph B. When I look over at 1 on my x value, it looks like it does match up with 3 because the graph passes through it. Let's see if I find 2 yards, if it matches up with 6 feet. So I'm going to go over to 2 yards and up. Oh, it looks like it matches with 6 feet. And this line is passing right through it. So I'm going to say B is the answer for this example problem. And let's go ahead and do number 5. Which of the situations best describes the graph at the right? So let's start with A. Each smoothie costs $3. Let's see if I bought 1 smoothie right here. It looks like it would cost $12. So that is not correct. Unless they were talking about smoothie on this side. Let's see. 1 smoothie. It's hard to tell the price. I'm just going to say no on that one. Part B. A runner can run 6 miles in an hour. I'm going to erase my lines from the last one. All right, 6 miles in an hour is what a runner can run. So let's go to 1 hour. See if it matches up with 6 miles. Nope. 6 miles in 1 hour? Nope. That one would be a half. So that one is wrong. Let's cross that one off. There are 12 cookies in a dozen. Let's see, 12 cookies in 1 dozen. That's correct. What if I doubled the recipe and I had 24 cookies? That would be 2 dozen. Yes, that's correct, and this graph passes right through both of those points. So let's go ahead and say C is the answer. And I know that the last answer, D, is not correct because it says it takes 6 hours to travel a mile. If I went to 6 hours right here and I went over, it looks like it would end at half a mile. So that's not correct. And that is it for today's notes. Hopefully you understand or were able to pick up on those. If you have any questions, please let me know.